Welcome to the advanced section of the hula hoop discussion. This is a bit more weird. This is what I think is happening when the hoop goes like this. And it involves a phenomenon called precession, which is actually what you get when something has spin. Now the Earth shows precession, and it's kind of a weird thing. It's kind of counterintuitive, and it uses gyroscopes use that. So I'll illustrate what happens with a toy gyroscope. This is a toy gyroscope, and I want to use it to demonstrate the weirdness of spin. Now it has a kind of circle around the outside, and then it has this bit in the middle which can spin. Now what I want to show you is I've got a string attached to one end, and I'm holding it the other end. Now if I release the other end, then, as you would expect, gravity pulls the whole thing down. The centre of mass will be about there, and it goes straight like that. Now, if I get it to spin up, let's see what happens. Whoa! It's creepy. You can see it is not falling down. As it slows down, it will gradually go down. And that is the weirdness of spin. That's precession. And it is quite freaky, and it feels weird. It really feels as if there's some weird, it's not an anti-gravity device. Let me point, some people have said this, but it's not, because I'm providing upward force by holding this. But what is actually happening is weird things are happening to the forces because of the spin. So usually there would be a twisty force which would take it down like this. Twisty force is called torque. However, when you've got this spin, what actually happens is that the force, the direction of the torque changes because of the spin, and it depends what direction the spin is in. So instead of falling down like that, it actually starts travelling round like that. It's dead weird and fantastic. So how does that apply to hoops? You can also see an example of precession and spinning tops, and if you spin your hoop on the ground like this, you can see what happens. But it doesn't just fall on its side, it kind of tumbles. I don't know if you can see that. But it's really quite cool. But you'll notice what actually is happening is it's kind of tipping from side to side. I can kind of do it with my hands as well. If I steer it like this, you can see that actually all the time different sides are coming up. It's kind of, I don't know how to explain it really. But that is an example of precession. So how does this affect what's happening with the hoop? Well, if you think with the hoop, what's actually happening is all the time it's tipping. So to go from there when it's on your front, to go to your side, some parts of the hoop are going up and some parts are going down. So my theory is that this is actually precession. So when you're moving the hoop, you're actually fiddling around a little bit with the speed. So the hoop is tipping at just the right speed for it to actually stay up and not spiral down your body like it would otherwise. You can also, I think, when you're taking it up the body, say up onto the chest, I think again you're fiddling with it, so it's actually tipping a little bit in the right direction, so it's actually spiraling up your chest. I can quickly illustrate how it can spiral up your body, like that. So that's how it might move. If I just send it off as well, down here, you can see it spiraling down. My theory is that it's precession which is actually allow us to hula hoop. It also explains, the spin at least, explains how sometimes hula hoops just don't do what you expect them to do. And it also helps me control my hoop, because, as I showed you with the gyroscope, it is weird when you've got spin in. So, if I'm spinning the hula hoop, and I want it to go from here to here, you would think normally what you would do is you would push out that side, and then it would be able to spin in this way. But that doesn't actually work. If I'm pushing that way, you can see it actually spins up over my head, and this again is the gyroscopic effect. So if I want to make it spin to go around this way, then what I do is I actually go, I drop it, I actually go out at the top and in at the bottom. Is that right? I can't remember. Let's see, no, in at the top and out at the bottom. Let's see. Yes, there we go. And this is because of the weird things which happen when you include spin in movement. But the basic principle, if you do want to move your hoop around like this, is to just imagine you're drawing a circle in whatever plane you want it to be. So if you want it in front of you, you draw a circle like this. If you want it to turn it so that it's going like that, and you draw a circle like that, and it will come round. So you always try and just have your movement in the plane you want the hoop to be in. So if I want the hoop to be in front of me, I can do up and down and side to side, but no in and out. If I go in and out, it's quite weird to feel it. It just kind of has a mind of its own. So, and if I want it to go behind me, I can go up and down, or side to side, and then it will go behind me. If I want it to go around, then I can go like that. So that gives you an almost superhuman control of your hoop. It does take a bit of practice. It's also a principle if you're wanting to go and do this vertical hooping, because what I find is I obviously go in and out a bit when I'm trying to do it, so the hoop actually drifts around like that. Anyway, it's a very interesting area spin, and I haven't really explained it properly, but I think it's important for hula hooping. So, anyway, thank you for listening.